Hello again. We've already talked about simplifying radicals, so we are going to talk about how to perform operations with those radicals. All right, so let's get started. The first two are addition and subtraction. Now, I want to remind you of what happened when we were dealing with variables or terms. We could only add or subtract like terms. So if I had something like 2x plus 3y minus 5xy plus 7x plus 8y plus 12xy, only the x's, which are in red, could be simplified separately. The y's, which are in purple, could be simplified separately. And same thing with the xy's that are in blue. So if I simplify those, my answer is 9x plus 11y plus 7xy. And I can't really simplify any further than that when I'm adding and subtracting. Okay, and so the same rule is going to apply for the radical expressions. And so whatever is inside of a square root is going to be treated the same way that a variable would be treated. Okay, so if I have 5 root 3 plus 6 root 2 minus 3 root 3 plus 9 root 2, only the things that have root 3 can be simplified together, and only the things that have root 2 can be simplified together, but I can't simplify them any further than that. So the 5 root 3 and the minus 3 root 3, which are both in green, simplify to give 2 root 3, and the 6 root 2 and the 9 root 2, both of which are in purple, simplify to give 15 root 2. Okay, and I can't simplify that any further than that. Now, sometimes I'm going to need to simplify each radical first because it hasn't been simplified like we talked about in the previous chapter. Here's an example. I've got the square root of 50 plus the square root of 27 plus the square root of 12 minus the square root of 18. Okay, I can only combine those if they have the same number under the square root, and it looks like none of them do. So it looks like there's nothing I can do here, but actually I can simplify root 50 to be 5 root 2. I can simplify root 27 to be 3 root 3. Root 12 can become 2 root 3, and root 18 can become 3 root 2 using those strategies that I talked about in the last video. So now I've got two terms that have a root 2, and I've got two terms that have a root 3. So I can simplify those. The 5 root 2 minus the 3 root 2 gives me 2 root 2. And then the 3 root 3 plus the 2 root 3 gives me 5 root 3. So now that is simplified, and I can't simplify that any further than that. Here's another example, root 45 plus root 28 plus root 500 minus root 63. I can simplify all of those to get 3 root 5 plus 2 root 7 plus 10 root 5 minus 3 root 7. Okay, and I can combine the root 5s to give 13 root 5, and I can combine the root 7s to give negative 1 root 7, which I can just write as negative root 7. All right, now multiplication. Remember, when we were doing expressions with terms, I can multiply pretty much whatever I want as long as I multiply everything separately. So if I have 2x squared y to the third times 3x to the 1 y to the 7 times 5x to the fourth y to the 1, the 2 times 3 times 5 is going to give me 30. X squared times x to the 1 times x to the 4. Remember, I'm adding those exponents and I'm getting x to the 7. Y to the third times y to the 7 times y to the 1 is going to give me y to the 11. Okay, the same rule applies for radical expressions. So if I have 5 root 3 times 6 root 2 times 2 root 5, I'm going to multiply all the numbers outside the radical sign first. So I get 5 times 6 times 2, which is 60, and then root 3 times root 2 times root 5 is root 30. And that's my answer. The radical can't be simplified, so that is my final answer. But sometimes I will need to simplify afterwards. So if I had 2 root 5 times 3 root 2 times 2 root 5, if I'm looking at the outside numbers, 2 times 3 times 2, that is 12, and 5 times 2 times 5 is 50, so my answer is 12 root 50. Well, 12 root 50 can be simplified, and I would get an answer of 60 root 2. All right, so that is multiplication. And lastly, we'll talk about division. Remember what we were doing when we were dividing terms. I could divide everything separately, just like I did with multiplication. So if I have 27 x to the 7 y to the 8 divided by 9 x to the 1 y to the 3, 27 divided by 9 is 3. X to the 7 divided by x to the 1 is x to the 6. Remember, I'm subtracting exponents. And y to the 8 divided by y to the third is y to the 5. The same thing is going to apply to radical expressions. So if I have 8 root 6 divided by 2 root 2, I'm going to divide the outsides separately and divide the insides separately. So 8 divided by 2 is 4, and root 6 divided by root 2 is root 3. Okay, so those are some basic operations with radical expressions. And so we are going to have more practice on this tomorrow. If you have any questions, please let me know, and I will see you tomorrow.